Imagine a world where artificial intelligence never sleeps, never pauses, never goes offline, because its brain is powered by its own private nuclear reactor. This isn't science fiction. Now some of the biggest names in technology, Microsoft, Google, Amazon, are exploring tiny nuclear generators to keep AI running endlessly. The question is, why? And what does this mean for our future? Part 1. The energy crisis of artificial intelligence. Its AI is hungry, and not in a metaphorical sense. Training the latest large language models takes gigawatts of electricity. For perspective, single training run for GPT-class AI can use as much energy as 100 US households do in an entire year. Now multiply that by the dozens, even hundreds of models being developed worldwide. Data centers, the brains of the digital age, are now among the fastest growing sources of energy demand. And as AI gets more advanced, that demand is set to skyrocket. The International Energy Agency warns that by 2030, data centers could consume as much electricity as the entire country of Japan. That's a massive problem for an industry that prides itself on innovation. And it's why big tech is looking at nuclear power. Just not the kind you're used to. Part 2. What are tiny nuclear generators? These aren't the sprawling nuclear power stations of the past. We're talking about small modular reactors, SMRs compact. Factory-built power plants that can be delivered by truck, ship, or rail, instead of producing gigawatts for entire cities. An SMR can produce anywhere from 1 to 300 megawatts. Perfect for powering a data center. And here's the key. SMRs are sealed systems. Many designs run on low-enriched uranium or thorium and can operate 10 to 30 years without refueling. Some next-generation versions even use molten salt cooling, making meltdowns physically impossible. They're not experimental pipe dreams either. Companies like NuScale Power, TerraPower, co-founded by Bill Gates and X-Energy, are already building and testing them. Microsoft recently posted a job listing for a principal program manager for nuclear technology, hinting at very real plans to integrate SMRs into their energy strategy. Part 3. Why AI and nuclear are a perfect match. 4:01 to 6 o'clock. AI models demand stability. They can't risk downtime during critical computations, especially in fields like medicine, climate modeling, or autonomous vehicle control. The current grid is vulnerable to weather, demand surges, and geopolitical energy crises. Nuclear solves that by offering constant, uninterrupted power, no matter the weather, no matter the market. For AI, this is like giving a marathon runner their own personal oxygen supply. And there's a climate angle too. AI companies face huge criticism for their carbon footprints. Nuclear is nearly zero emission. Switching from coal or gas to nuclear could cut a data center's carbon emissions by up to 99%. Part 4. The safety and controversy, but the word nuclear still sparks fear. Images of Chernobyl and Fukushima loom large in the public's mind. That's why SMRs are designed to be different. Many are built underground for security, use passive cooling systems that require no pumps or human input, and are designed to shut down automatically if anything goes wrong. Some even produce nuclear waste so minimal that it can be stored on site for the life of the reactor. Still, there are concerns. What happens if AI systems become overly dependent on these isolated nuclear plants? Who controls them, and could they be hacked? And what happens if geopolitical tensions rise over access to nuclear fuel? Part 5. The future. The fusion of AI and nuclear power is not a maybe, it's a when. Regulators are warming up to the idea, and tech companies know that without a stable, massive power source, the AI revolution could stall. So in the next decade, the brains of AI may well be nuclear-powered, running 24/7 on compact reactors hidden deep underground. Will it make AI unstoppable? Possibly. Will it change the global balance of power? Almost certainly. We've given AI vast amounts of knowledge and processing power. Now, we may be giving it the one thing it needs to truly never stop: endless, independent energy. The question is, when the machines never have to rest, will we?